camera from going like this. Welcome grade 8s. We're doing 5.3 solving percent problems in real life. And I'll ask the rest of the class to be very quiet so that we can get this video done in fine honor. So the first thing I want to talk about here is a percent of a percent. Usually this gets kids struggling a great deal. A percent of a percent is a very small thing. So for example, if I said that 30% out of 60%, like let's say I said 60% of the people here will get public sector jobs. And of those 60%, only 30% of them will have those same jobs after 10 years. Well, this is where a kid walks out of class and goes, well, Mr. Ewert said that 30% of us are going to get public sector jobs for more than 10 years. No, I didn't. What I said was that 60% of you would get public sector jobs. And that of those 60%, only 30% of that 60% would get public sector jobs.
That's 1/3.
Does that look like a third?
No.
No.
Oh.
And so whenever we have percent of a percent, it gets smaller. So I just want to get that out of the way right now. Now, we've done a lot of problem solving with block models. It's going to help us today. So first we're going to look at this problem right here. I don't want to segue. I want to get this done. So we're going to talk about this problem here. It said Tasha had a survey of students and found that 60% of them rode the bus. So here I'm going to draw my little block. And it says 60% of them, probably about there, rode the bus. And then Liam, he knows for a fact that 450 kids go to school by bus. So let's see, if I think, then that means 60% of the population is 450, because if 60% ride the bus, and 450 kids ride the bus, now I've got an idea. Now, but the question that's going to be asked here is, how many kids, can you pass me the mouse by the tray there, please? Careful, the camera just moves when you move the cart there. I want to find out how many kids can go to the school in total. And we'll come back to this part. It says, how can Liam use the data to find the number of students in the whole school? Yes? Well, I know, I'm going to show you how quick. Okay. Should we pause the video first and see if you can take a crack at this? Okay, let's pause the video. We started coming close to some ideas about how we can break this up. And so I said, well, what if 60% or 6/10 of the population was 600 kids? And almost right away, Jim Bob here said, it's 1,000. And then Mary Sue and Agatha went, yeah, it's 1,000. And they couldn't figure out how they'd work that out. But you see, if I were to say, well, if 6/10 is 600, then 1/10 would be, how much would 1/10 be? It would be 100. So then I'd have 400 more on the other side. Well, we're going to do something kind of similar over here. I'm going to take my calculator for this one, because I'm going to take 450, and I'm going to divide it. And I want you to see how. Watch this. What if I cut this into 60 pieces, and each one of them is worth 1%? And I found out what 1% is. Now, we know that this is 450. So I'm going to cut it into 60 pieces. 450 divided into 60 pieces is 7.5. That means 7.5 equals 1% of the population of the school. How many people right now, if 1% is 7.5, can figure out how much 100% of the school is? Got a few hands coming up. Okay? So if 1% equals 7.5 kids. Oh, I see. Okay, so I had a student here say times it by 40, and I know what's in here. Because that's 40%. We could do that. Yes, we could take 1% times 40 and find out what's in this box. Absolutely. Yes.
You have to do both 40 and 60, so 100.
So if 1% is 7.5, then 1% times 100 will give us the whole school. Absolutely. So here's my formula. My formula is 450 over 60 times 100. 450 gave us 7.5 times 100, so we have 750 students in the school.
Wait, could you do it times 40 and then add it? Whatever number?
Yes, we could. So one suggestion that I had here was, well, why don't I take, once I figured out 7.5, could I go 7.5 times 40 here? And then that would give me, what is it, 300 there. Yes, you could do that. 300 is 450. Now let's look at the end of the question. It said, Tasha also found that 50% more students go by bus than walk or drive. Are there 50% more students here than there?
No.
I got mixed responses here.
It's like 50.
What is 50% of 300?
150.
150. Is there 150 more? Yes, there is.
Oh.
So she says, Tasha found out that 50% more than 300 is 450. And that sure enough, there's 50% more kids riding the bus than walking or driving. Now this is looking a little complicated right now. Some of you are like, yeah. Some of you are like, yeah. And some of you are going, give me some more. So let's take another example here. All right. Grady is 13 years old. Oh, okay, here we go. Who wants to find out how tall they're going to be when they're done growing?
Me.
Okay, right on. So we're going to find out real quick. We're going to do grade Gladys, I think it is in the textbook. So we're going to find out her final age, or her final height. By the way, I don't know if this is actually like a medical fact, because I noticed like at your age, a lot of the girls get taller and then the guys start to catch up and then the girls get more mature and the guys, well, never mind the guys. Okay. So Gladys found out that she is 155 centimeters. And she is, I have to ask that the conversation stop because this is video going out and we want this as a lesson. She's 55 centimeters and her doctor said, well, Gladys, now that you're 13 years old, you've got 10% more to grow. You're going to grow an additional 10%, or I should say you are 90% full grown. It's 90%. Well, wait a minute. If I'm 90% full grown, and 90% is 155, then how tall will I be? Can you pause the video for me for just a second? All right, we're back. So Gladys says she's 13, she's got 90% of her height grown. She measures at 155, so we want to figure out what Gladys is going to be when she's full grown. So let's cut this into 90 pieces. 1, 2, 3, 4. Oh my gosh. Do I have to go through the whole thing?
Yes.
No.
Yes.
No.
No! So I'm going to take 155 and I'm going to divide it by 90 because that's going to tell me what 1% is. Does someone have my calculator? I have my calculator. So I'm going to take 155 divided by 90 and it says 1.7222222 forever. So that means forever. Okay, I'm getting there. So I know 1% of her height is 1.722222222. Now I need to times it by 100 because I know what 1% is, but I want to know 100%. That's going to be 172.2 centimeters tall. That's what she can expect to be when she's full grown. So we'll pause it real quick and find out how tall you guys think you ought to be. Pause. All right, thank you. So we measured, we found out some tall people. At one point when we were measuring Jim Bob here, he came out at -100, so we figured he'd be very, very short, suborbital. However, I'm sure we made a mistake and then we righted the situation. So to review this, if you're 155 and that's 90% of your height, you just cut it into 90 pieces. find out what 1% is. If this is 1%, times it by 100, you know what the full kit and caboodle ought to be. Now I really hope I don't find out that kit and caboodle is a very inappropriate thing because I'm putting it on YouTube. Alright, let's go to some quick examples in the other direction. So here's Gladys. Gladys did 155 over 90 times 100, just like we did, got the same thing. So it says, find the number in each case. It says 70% of a number is 63. So we've got 70% of a number is 63. That is 70%. Since we're having 70% of 63, we're going to cut that into 63 pieces. No, we're going to cut 63 into 70 pieces. 63 divided by 70 times 100. Once we do that, 63 divided by 70. 63 is divided into percents times 100. And we have 90. So we found out that the overall is 90. Here it is once again, 70% is 63. So that's 63 divided into 70. So you can find out what 1%. 1% is this. Take that 1% times 100 and find out that 100% is 90. And then you can follow the second one on your own as it's exactly the same. All right. A length of 30 centimeters increased by 40%. What is the new length? 30% increases by 40%. What's 100% as a decimal? Well, if 100% is 1, and if 40% is, call it out,
0.4.
0.4. 1.4, okay. So if I had 30 centimeters, and that was 100%, but then it grew by another 40%.
You have 70.
What?
Oh, you have to do 40% of 30?
I could. There's two ways I can think to do this. One, I could go 30 times 40%, and I would get 12.
Oh, it's so simple.
But wait, I could also do this. %140% equals 42. Let's see if we got it right, because I just did all that in my head. So we had 40% as a decimal is 0.4. They did it the first way like we did. We said 30% times 40% is 12, and then we added it on. Or we could have just done it one step and gone 1.4.
Okay, wait, how would you get the same? Oh, because then you add, okay, never mind.
I think you just clicked.
Yeah.
You just got it.
I was like, how?
All right. Now, this is where we now go on to that number line thing, and this is where I'm not going to draw it because it's right here. I know the number line, but just wait. 0%, 100% is 30. Then we added 40%. Didn't we just draw a number line right here? The only difference is I did it as boxes. And most of you can do the boxes for the Singapore math pretty well. Take a look at this. In your assignment, when it says number line, go here. All right, I think I'm going to wrap it up on that one. I think most of you are doing reasonably well, but I think we definitely have some questions. How many of you are up here on your understanding at this point you feel? How many of you are like around there? Okay, we got me this. That's cool if you're there. All right, if you're there, come hang out with me up at the front. I look forward to working with you. Thank you, YouTube land. We'll see you later.